Hello once again and welcome to our virtual classroom. Today we are going to be going over lesson 2-2, which is all about exponents. Again, feel free to pause or rewind if I'm going too fast or you just need to hear something over again. That way we can all be on the same page. Now, when dealing with exponents, all you need to remember is that an exponent indicates repeated multiplication. As we can see here on our very notes, and I do encourage you to copy down this table. An exponent will always be a smaller number to the right of and on top of another number, like we see here, 3 raised to the power of 4. And what that exponent tells you guys is how many times you're going to be multiplying that number times itself. Again, how many times you're multiplying this number times itself. So in here, in essence, we are being told that there's 4 3s. 1, 2, 3, 4 being multiplied together. That is all of what that means. Now, please do not think of this as a number 4. There is no 4 here. In fact, when I expand this, all I get is 3s. All it's telling you is how many of this number are being multiplied together. So 3 to the 4th power literally means 3, that's 1, times 3, that's 2, times 3, that's 3, times 4, that's 4. So 3 to the power of 4. And when I multiply this out, well, 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. Another way you can work that out is 3 times 3 is 9, 3 times 3 is 9, and then 9 times 9 is, again, 81. It doesn't really matter how you evaluate it. It doesn't matter how you work it out because it's multiplication. The order doesn't really matter. You're going to get the same answer. So 3 to the 4th power is 3 times 3 times 3 times 3. Then 3 to the 3rd power is not 3 times 3. It's actually 3 times 3 times 3. 3 3s being multiplied together, which gives us 27, because 3 times 3 is 9, 9 times 3 is 27. Similarly, 3 to the 2nd power is just going to be 3 times 3, and 3 times 3 is 9. And 3 to the 1st power, again, this tells me how many 3s there are. There's only 1 3, so there it is, and 3 is just equal to 3. Now, this next one, I'm not really going to explain it, but I do need you to know that anything raised to the power of 0, like 3 raised to the power of 0, is actually equal to 1. Now, I know that's going to be really confusing to some of you guys, but I need you to just remember that anything raised to the power of 0 is equal to 1. There is an explanation, but I don't want to risk confusing you with it. Just know that anything raised to the power of 0 is equal to 1. So if we have 5 raised to the power of 0, then obviously that's going to be 1. 1 to the power of 0 is 1. 10 to the power of 0 is going to be 1. So ladies and gentlemen, again, anything raised to the power of 0 will always be 1. Now, a few more things to keep in mind. Whenever you have something written with an exponent, like we see here, we call that exponential form, which makes sense because we have an exponent, so that would be the exponential form of the expression. Now, whenever you expand it out, whenever you actually write down the numbers that you're multiplying together, like instead of 3 to the 4th, you write 3 times 3 times 3 times 3. That is known as expanded form. Expanded form. It's like we're expanding the expression into what you actually see. Now, over here, I didn't write anything down, but you can write evaluate or evaluation. Because whenever you are given 3 to the 4th power and the instructions are to evaluate, what they're saying is work it out. In other words, what is actually the answer going to be? So that's what it means to evaluate something. So that would be the evaluation of the expression. A few more terms, ladies and gentlemen, when you have an exponent, the number that you're going to be multiplying times itself, that is known as the base. Notice that it's the bigger number, it's the one on the bottom, so it is the base. And the exponent is known as the exponent or the power. Sometimes it's also called the degree in certain contexts. But yes, exponent or power will do. And that's pretty much how exponents work, ladies and gentlemen. Just one other thing that I want you guys to keep in mind is some special cases. What do I mean by special cases? Well, for example, here we have 5 to the 2nd power. Okay, 5 to the second power literally means 5 times 5, and I know that that is 25. However, ladies and gentlemen, what I want you to know is that when something is raised to the power of 2, another way of saying 5 raised to the power of 2 is to just say 5 squared. Yes, like a square. That's how you say it. 5, anything to the power of 2. So if we have 7 to the power of 2, you would say 7 squared. 3 to the power of 2 would be 3 squared. Anything, again, ladies and gentlemen, anything raised to the power of 2, you can say, instead of saying raised to the power of 2 or to the power of 2, you just say squared. Similarly, when something is raised to the power of 3, then you say cubed. Yes, like a cube. Like an ice cube. That's how you would say it. There is a reason for that, for saying squared or for saying cubed, but we'll cover that more in more detail when we do geometry. But yes, so 5 to the third power, yes, that means 5 times 5 times 5. Instead of saying 5 to the power of 3, you would say 5 cubed, or 7 to the power of 3, that would be 7 cubed, and you'll hear me say that quite a bit. Lastly, guys, for the assignment today, found on Schoology. Actually, it's not this one. I'm sorry. All of what you had to do, ladies and gentlemen, is really just evaluate these expressions. All you're doing, guys, is actually expanding these out, and I do want you to expand them. So 2 to the fourth power would be 2 times 2 times 2 times 2, and then you would actually work it out. 2 to the fourth power would equal 2 times 2, which is 4. And then 2 times 2, which is 4, so that would actually equal to 16. So you would just expand these out. Now, some of these are harder than others. For example, 8.3 to the second power. Well, it's just 8.3 times 8.3. It's 8.3 times itself twice. So you would just work that out. Again, how do you multiply decimals? That's something that we've already covered. Remember, anything raised to the power of 0 is always going to be equal to 1. And yeah, it's all about just thinking through these problems. They're not really that difficult, and so I hope that you don't have a hard time doing these. I think today's lesson was pretty simple, ladies and gentlemen. Obviously, if you have any questions, you can ask me. And with that in mind, I will see you next time.